As we wrap up our chapter on rational expressions, we're going to actually look specifically at rational equations. But first, let's look at the difference between what is an expression and what is an equation. When we simplify an expression, we are looking to make an expression into a simpler but equivalent form. One way to notice if it's a rational expression that we're simplifying using the methods of multiplying, adding, or the complex fractions that we've seen in the past is that there is no equals in an expression. Contrast this with when we solve equations. When we solve equations, we're looking for the variable values that cause both sides of an equation to have the same value. And the big thing that we're going to have here is, yes, there is an equal sign. If there's an equal sign, we can figure out what the x, or whatever the variable is, equals. Now with rational equations, not expressions, because now we have an equal sign. When we simplify these equations, we can do that by clearing the fractions. And we do that by multiplying both sides by that least common denominator of each term's denominator. However, this technique only works, we're only allowed to clear fractions like this because we are solving equations. Do not try and do this to simplify an expression. In order to do this method, we need an equal sign in the original problem. We can't just do it to simplify like multiplying rational expressions or adding rational expressions. Cannot do it then, just when we have that equal sign. Now, in order to find that least common denominator to clear the fractions, we might have to factor the denominators in order to find the least common denominator. Also, one thing to be very careful of is as we reduce, we might be reducing out something that creates a false solution that does not actually work because we've reduced it out. So we need to make sure we don't forget to check our answers. We might have a solution that caused the denominator to equal 0, and the denominator of a fraction can never be 0. We call these extraneous solutions. Solutions that look like they worked, but they don't actually work. And that's why we have to exclude them from our solution set. Let's take a look at a couple examples where we can see this process work out. It makes a lot more sense when we just see these examples. Our first example we're going to take a look at is 3 over x equals 5 over 7x minus 4. Now again, as usual, when something's not written as a fraction, we can make it a fraction by just putting it over 1. And now we can look at our denominators. The first thing we're going to look for is what's not allowed. The denominators, this first denominator is x, cannot be 0. The second denominator, 7x, cannot be 0. And if I divide both sides of that by 7, we get x cannot be 0. So x cannot be 0. Other than that, we're going to solve using this method of identifying the least common denominator. In this case, we've got x's, and the numbers 7 and 1 have a common factor of, or a common multiple of 7. So we're going to multiply both sides of the equation by 7, and that multiplying by 7x is going to distribute all the way through. When I do that, we can do some reducing. Notice the x reduces out, the x and the 7 reduce out. So I'm just left with 7 times 3 is 21 equals a 5. Minus 4 times 7x is 28x. And this gives me an equation we should be able to solve quite quickly. We'll subtract the 5 from both sides to get 16 equals negative 28x. Divide both sides by negative 28. And we can reduce that by dividing by 4. Gives us negative 4/7 for our answer. Take a moment to check my unallowed values of 0. Didn't get 0 for an answer, so we're good to go. This is our solution to this rational equation. Let's try a second example. Let's try 4 over x plus 5 plus x equals negative 2 over x plus 5. Again, the first thing I'm going to do is notice that that x can be rewritten as over 1, so it also is a fraction. Also, my not allowed values, both of these x plus 5s match, so we only have to do it once. X plus 5 is not allowed to be 0. Subtract 5 from both sides. X is not allowed to be negative 5. So let's see what happens when we identify our least common denominator. Well, the only denominator I see is x plus 5. Technically a 1 times x plus 5, but multiplying by 1 doesn't really change anything. So I'm going to multiply each term on both sides by x plus 5. And when I do that, the x plus 5s reduce out on the left. The x plus 5s reduce out on the right. So we're left with 4 plus, distribute the x through, x squared plus 5x equals negative 2. We know with a quadratic, when we see x squared, we want it to be equal to 0. So we're going to add 2 to both sides, giving us equals 0. Also, putting it in order, we have x squared plus 5x plus 6 equals 0. We know how to solve that by factoring. That's x plus 2 times x plus 3. Set each factor equal to 0, so x plus 2 equals 0 and x plus 3 equals 0. Subtract 2 from both sides, x equals negative 2. Subtract 3 from both sides, we get a second answer that x is equal to negative 3. Double check, none of those answers are the negative 5 that's not allowed, and so we're going to call that our final solution. This time we have 2 answers for x. That's the general idea of solving these rational equations, is we're going to multiply both sides by the least common denominator. But sometimes they require a little bit more work. That's what we're going to take a look at in our next video.